Okay, hello, and a warm welcome to you all attending this panel discussion on Wanna Be a Climate Warrior, with a special mention to the third year UGs who are considering to register for a dual degree program in climate studies. I'm Vishal Dixit. I'm an assistant professor at IDP Climate Studies, and I'll be the moderator for today's panel discussion. Now that the institute is slowly coming back to its normalcy as it was around 3 years back, I can safely congratulate you all on successfully combating COVID-19. I hope I am not too early on that. One peculiar thing we all observed during this global emergency was that those countries, those communities, or those societies who paid careful attention to the details of scientific, social, economic, cultural, and so on. I mean, all these aspects kind of ultimately could prepare themselves better for what was coming, or in some cases, also to face consequences. So those who had the right training to handle emergencies also kind of contributed to as a corona warrior, and in the process also won lots of well wishes, accolades. But not only that, there were also corona warrior businesses who actually recognized this opportunity to provide solutions during the emergency and made a global imprints. Just remember the CEO of Bharat Biotech who visited our campus a couple of weeks ago. So in some sense, those who understood the science behind and adapted to the changing situations, they managed the situation well. Okay, now let us consider the climate change as a global emergency of similar kind, but with far-reaching and kind of sustaining consequences and repercussions. So we all will agree that we will be able to face it at least gracefully if we educate ourselves more about the problem and, in some sense, also think about the ways to combat it. We have realized huge role climate plays in our day-to-day lives, be it the food that we eat, our energy demands, the water stress, or in fact, the way we live itself has huge role of climate. So naturally, I would say the future belongs to those who understand the role of climate in details of what we do, and in some sense, then take that as an opportunity to offer solutions in to people in handling climate change. I hope I have with this I have kind of given you some background about why we named this panel discussion as "Wanna Be a Climate Warrior." So with this background now, let me invite Professor Subimal Ghosh to talk about interdisciplinary program in climate studies and introduce this dual degree program to you all. First, to introduce Professor Subimal Ghosh, he's currently serving as a convener of interdisciplinary program in climate studies, and he's a professor in Department of Civil Engineering at IIT Bombay. His research interests include hydroclimatology, regional climate modeling, understanding of Indian monsoon and its variability, mesoscale hydrological modeling, land surface feedbacks in understanding of climate. He has more than 100 journal publications, some of them being in very prestigious journals like Nature Climate Change, Nature Communications, Science Advances, Geophysical Research Letters, Water Resources Research, etc. He's also been conferred with prestigious awards from American Geophysical Union, and he's a recipient of AGU DL Memorial Award, Shanti Swarup Bhatnagar Award, a prestigious Indian prize, Swarna Jayanti Fellowship, PRL Award, Dr. APJ Abdul Kalam Cray High Performance Computing Award, and many more. He's also served as a lead author in IPCC Assessment Report 6. With this, I now hand it over to Professor Ghosh.
Thanks, Vishal, for the introduction and for conducting the this panel discussion. And thanks to all the panelists for joining today's panel discussion. And I mean, on behalf of Climate Studies, I welcome all the attendees for joining this panel discussion. Now I'll share one of the slide to to tell you a little bit about IDP Climate Studies as well as what is IITB in Climate Studies. What do you mean by this? So when you're talking about IITB in Climate Studies, we are essentially telling about interdisciplinary dual degree program in climate studies, where any students who are doing undergrads in any of the departments, from third year, they can enroll for a master's degree in climate studies. And at the end of 5 years, they will be getting BTech plus MTech, BTech in their individual department and Masters in Climate Studies. This is what IITB Interdisciplinary Dual Degree Program in Climate Studies. Now, I'll first give you a brief introduction about, uh, our IDP Climate Studies. So this interdisciplinary program in climate studies was set up in 2012, January 2012. With support from Department of Science and Technology, which was Department of Science and Technology's Center of Excellence on Climate Change. And this is the first doctoral program in this country focusing only on climate change, where we are focusing on all the three areas of climate science, climate adaptation, and climate mitigation. So earlier, there are many other centers where there are PhD programs. They are either on climate science or climate mitigation and so on. So all three areas together and bringing this under the same umbrella. This was the first of its kind in this country. Now, as we all know that, last 2021 was a major year for climate studies and climate change. The IPCC report was out, and after that we had the COP26 meeting. And immediately after the IPCC report was out, it was shown that climate is changing. The changes are unprecedented, rapid, widespread, and these are having a serious impacts on everyone, everywhere around the globe. And it was termed as, code red for humanity. And it has gained a lot of media attention. And after that, the entire COP26 meeting was on, what are the solutions and how to really go ahead with this. So, and at the same time, 2021 was the year where we have Nobel Prize in Physics. So Dr. Manabe and Dr. Hasselman got the Nobel Prize in Physics in 2021 for their work on physical modeling of Earth's climate, this variability, and showing that in what way the climate models can be used for climate projections, and we can essentially find out what are the human contributions to climate change and future projections. So that is sort of a very preliminary work, basic work that based on that actually created the foundation of the climate science. So those were very important, and based on that, of course, now we are going for 21st century. Next 100 years, how will be the situation if we keep on increasing the greenhouse gas emissions? And we are showing that, the climate scientists are showing the future is not very good. It's actually terrible. And climate has already started changing. We can see the changes which are actually taking place, and the future is becoming, it's not a very good future which is waiting for us. So we need solutions. So so why do you need solutions? So essentially what we have been doing is that we are focusing on climate science, and we are only talking about the problems mostly. And so I'll go back to again two of the Nobel laureates in economics, Professor Abhijit Banerjee and Professor Esther Duflo. So what they have said is that talking about the problems of the world without talking about some accessible solution is the way of paralysis rather than progress. It's a very important point. So when you're talking about a problem, of course you have to provide the solutions, and the solution has to be implementable, which is a very, very important point. And I'm very happy to say that interdisciplinary program in climate studies, it's not only, as I was mentioning, it is not only focusing on climate science, but our major emphasis now is on climate services and solutions. In what way we can improve the climate services, in what way we can provide the solutions, and it has to be interdisciplinary. Let's say if we have to provide certain climate solutions for health sector or agricultural sector, you have to understand health or agricultural sector. For example, let's say if you have to apply your climate solutions for agricultural sector, you have to understand hydrology, you have to understand agricultural science, you have to understand electrical engineering for better monitoring of soil moisture, you have to understand systems and control for automated drones for monitoring and so on. So it's essentially an interdisciplinary area. So this interdisciplinary flavor is very, very important for any kind of design of climate services and solutions. Now, for this purpose, so let's say if you're talking about climate change modeling, or for any kind of climate services solutions, we actually consider multiple areas, as I was trying to say. We are considering physics for atmospheric physics, we are considering chemistry for atmospheric chemistry, we are considering chemistry for carbon sequestration design, and many we need hydrology for understanding water management, water security, and so on. We need AIML and big data, because when you're talking about climate services, when you're talking about climate data, it generates gigabytes of data. So you need to really handle the data. We need big data approaches. There are huge number of, there are growing number of monitoring or observations based on satellite, based on multiple sources of multiple sensors, multiple sources. So you need to merge all of them using artificial intelligence or machine learning, understanding processes, and then applying it for certain developing solutions. We need core, computational fluid dynamics, which is a core part of mechanical. So we need ideas of mechanical engineering, ideas of computer science, ideas of civil engineering, physics, chemistry, everything. Everything is chemical engineering and so on. And most importantly, whatever engineering or design or scientific development now it will take place, it should have a component of climate, because it should not result into huge greenhouse gas emissions, or it should not result into it should not result into something which is not really sustainable under a severe climate extreme condition and so on. So any design which is being a transportation design or infrastructural design or agricultural design or river interlinking or whatever, it should have a very strong component of climate. So you may be in different engineering disciplines, but down the line after 5 years or 6 years, when you have to develop the design, there should be a strong climate component, and without the understanding of climate, this kind of component cannot really be included. And there we have climate scientists have a lot of scope to work and develop, not only developing newer ideas, newer technologies, but also even coming up with newer startups, newer companies, so that India can be a leader in this specific area. And as you can see that our center is an interdisciplinary center where under single umbrella we have core faculty like Vishal, and at the same time we have faculty members from different departments. We can see around 12 departments were involved, 32 faculty members from 12 different departments. They are working together under the same umbrella. So that makes the center really, really interdisciplinary. And of course, there is a huge number of student intake, which has been increasing because students are really interested and they are enjoying really this kind of topics, which are interdisciplinary, where we can actually use the out of the box thinking. Now, this is the key areas. I'm not going into detail, but as I told that we need a thorough understanding of climate science. We need to understand sector specific impacts and adaptation. We need sector specific knowledge, and we should have the mitigation ideas, and all of them we need to brought together for developing a newer climate services and solution techniques, being it as agricultural drought monitoring, agricultural management, or flood forecasting, or crop planning, or some kind of ecological restoration or carbon capture, health. Sorry, for everything, if you really need to generate climate services and solutions, you need the understanding of science, adaptation, and mitigation. And this is the center which can give you this kind of ideas and knowledge. Now, of course, we had a discussion when I took over as the convener of climate studies. I had a discussion with Professor Subhashish Choudhury, our director, and he suggested that climate studies should have an IDDDP program where the students from different undergraduate programs can do a dual degree or masters in climate. So we set up a committee, thanks to Professor Shubhankar Karmakar, who was the convener of this committee, and Professor Trupti, Professor Sridhar, Professor Manas, Professor Kartik, all of them designed this course structure. So this is as per we are not really making many specific change for this. We are following the UG rule book. So as per the undergraduate rule book, at third year, if the student has more than 7.5 of CPI, they can apply for it. And we are starting with 5 students per year. So our maximum intake is 5 students per year. But of course, if there is a lot of interest, we will definitely increase. So maybe we'll go for a master's program also. So the course structure would be like this. So one of the very important thing what I'd like to say is that if you do BTech plus masters, it will take 6 years. Now here you are doing it in 5 years. If you are doing masters, you have to do almost 10 courses. But here what we are doing is that you are actually doing 4 courses, where we will have a core course, an introduction to climate change. And there will be, you have to take 1 policy elective and 1 science elective. One is policy track elective course and one is science track elective course from IDP Climate Studies. And the third course or fourth course, it can be either from science or from policy, depending on your project. And then we'll have in the third year or fourth year, you have to do a seminar. And this is more project based. So you can see that we are actually giving a lot of credits for the dual degree project. So we want the students to spend entire 5th year, that means the final year, on the project. so that at the end of the project we'll come up with a newer kind of out of the box ideas, thinking, or some newer kind of services, solution technologies, and so on. So this is our target. So, and it should be interdisciplinary. Let's say if you're talking about a student, if let's say a student from computer science, if he is interested in doing a dual degree in climate studies, he knows different computer science techniques. Now he will start applying here in climate studies, come up with newer understanding of processes, or some kind of a computationally inexpensive model for weather forecast with the existing model outputs and so on, and which can give a better forecast with a relatively less time than the conventional approach. Then these kind of things will actually is really very, very useful. And even I can tell you, if you can develop this kind of things, you can actually come up with an weather company, and and you can make a lot of money. So that's the way it is being designed. And this is the list of courses. Of course, these are available also in our website. If you go for ITP Climate Studies, go to our website, you will get all the details. So thank you. Thanks for your patience. And yeah, and again, and once again, I'll thank all of you for attending this. Thank you very much.
Thank you, Professor Ghosh. I think what you just said probably will be even more clear when our panelists share their experiences, their journey, and the interdisciplinary nature of this will be even more evident. So with this, let me now move on to introducing panelists. So I'll begin with Professor Raghu Murtugudde. It's a pleasure introducing Professor Murtugudde. He has had an illustrious career as a professor to several generations of researchers. He sent me a very modest kind of introduction, which I will read out to you. But please visit his website because his biodata is several pages. So Professor Murtugudde did a BTech in aeronautical engineering from our own IIT Bombay, and a PhD in mechanical engineering from Columbia University. He worked at NASA GSFC as a research scientist, and at the University of Maryland as a professor of atmospheric and oceanic sciences and earth system science. He's currently a visiting faculty at IITB, so we are fortunate to have him at our department. Over to Professor Murtugudde, if you can share your experience and inspire third year UG students to take up this course and this challenge of climate change.
Right. Thanks, Vishal. Several generations of, I have to be pretty old to do that, considering each generation will be 25 years. But yes, I did a BTech here, did experimental fluid dynamics. I did a master's in Texas, also experimental hypersonic stuff. And then I worked in aerospace industry for a few years. I actually lost my job because that project was, funding was removed by the US government. So then I went back to a PhD in Columbia University and moved into CFD. At Columbia University, I had a brief opportunity to help with some numerical methods to a climate group. And after PhD, I had to again choose whether I want to go back to the industry or stay in research. And I decided to give up good jobs and take like a 50% pay cut and go join NASA as a postdoc, and then became a research scientist. So when you choose such a career in academia, you do lose money, but the freedom is unbeatable. You teach for 8 months, and 4 months I've been spending in India since the 1990s, working with farmers on some issues, sustainable agriculture and water management. And then my research has focused on various things, tropical climate, basically ocean's role in tropical climate. So I will stop there and just tell you that life can be a random walk. But after having gone through that and made a choice of staying in climate, I can tell you when I started, it wasn't such a hot topic, but now it is. So it's really a good place to try to contribute something and make an impact. Okay.
Thanks, Professor Murtugudde. Now I will move on to our next panelist, Dr. Rajul Patkar. Dr. Rajul Patkar is a co-founder and chief executive of Proximal Soilsens Technologies. She is a principal investigator for many technology-based projects funded by Government of India like Bayrak Sparsh, Atal Niti Ayog, Nidhi Prayas. She has completed her MTech PhD degrees from, again, our own IIT Bombay. She has more than 15 years of experience in reconfigurable computing, embedded systems, VLSI chip design, FPGA, MEMS fabrication, and biosensing. As a research scientist at IIT Bombay, she has worked on many key agri and non-agri domain projects sponsored by MIT, Government of India, the India Trento project in agricultural research, and various industries like Tata Infotech, Siemens, Sealing, Bark, etc. She has published her work extensively in top international journals and conferences. In addition, she has filed multiple Indian patents and has a US patent. Her work on low-cost sensor devices for point-of-care applications in agriculture is now a part of the company's product portfolio. With an understanding of ground realities and limitations in the agri domain, she is working towards mitigating these challenges. We are very fortunate to have you today with us, Dr. Rajul. Over to you.
Thank you, Dr. Vishal. It's not that much of work, whatever has come from you, but yeah, at least something I have done and I'm trying to do. So thank you. So good evening, everyone. And thank you, Professor Subimal, and again, Professor Vishal, for inviting me onto this panel. It gives me immense satisfaction because I'm talking to very young climate warriors here. Who are going to be probable climate warriors, and which is very much required, I feel. So as my journey into, climate change or something, I'm actually an engineer by profession, which you would have understood that I'm basically an engineer. So when I registered for my PhD, I did not have an idea about climate change or agriculture or sustainability. But what I knew that I had a lot of research ideas in mind, but one thing was very clear to me, that whatever I take up as a problem during my PhD should create a social impact. So with that clarity in mind, I was not what to take. So I had read about sustainability, climate change, mitigating climate change, agriculture, sustainability only in the newspaper reports and articles on internet. Had there been a course which being in IIT Bombay, I was not even aware of such. Maybe I should have attended some of these courses, what Professor Subimal has talked about. But yeah, so whatever I have learned currently is on the go, kind of. Whenever there was a need, I just learned things and just moved on. So when I started looking at climate change, when we talk about mitigating or adapting climate change, the agriculture comes as one of the forefronts. Like, we have only 4% of world's water resources, but we have 17% global population. So India is a host to 17% of global population. So it becomes very important for us to look at water conservation. Apart from that, what happens is that indiscriminate use of fertilizers in agriculture. So the production of fertilizers, the use of fertilizers releases nitrous oxide, carbon dioxide. We all talk about CO2, but nitrous oxide is much more harmful than CO2. It is 300% times more harmful than CO2. So, but what happens is that in India, if you see 85% of our farmers are marginal farmers. And if we talk about climate change to them, I think they are hardly bothered about this big problem. They are actually trying to solve small problems of their day-to-day problems. So they just don't care about this climate change or water conservation or precise use of fertilizers. And the other part of that, other thing is that there are no technologies which were actually designed for these small farmers, which are 85% of our Indian agriculture system. So as the what, and they are not, for them, the major motivation is to improve the productivity. Thanks to our green revolution, which was actually, that was the need of an hour. Every farmer now thinks that more the fertilizer, more the productivity. They don't realize that over the time, few decades down the line, there won't be any agriculture if we don't, start taking action on it, start using fertilizers precisely. But how do we actually approach these farmers? This is a very difficult thing because these technologies are not meant for them. They are not, they do not have, and I would say even they do not have an intent. They do not even have the capacity to implement these technologies. So at Soilsens, what we try to do, that we understood this problem, that if we really want to bring a change, bring a revolution, or bring a social impact, we have to target these farmers. We have to build technologies to reduce fertilizer use, to reduce water usage for this 85% of the farmers. Every company in India or abroad are only work for those 15% of cash crop farmers who can actually pay for the technology. So our work in that way, we were a bit successful also because as an UNDP has acknowledged our work and published our work in their UNDP report. And apart from that, at Soilsens, our focus is to build these technologies, create awareness among these farmers, take these technologies to the farmers, hand-holding to the farmers, and make sure that at least understand the need of this and they understand that if they don't act on it now, there won't be any future in agriculture. So as a closing statement, what I would like to say is that because there are a lot of BTech students, if you are doing a good work, money will follow. That is my point of view, and thank you for this. And now I think I'll close my talk here.
Thank you, Dr. Rajul, for sharing your personal story as well as really telling making an appeal to the students with your personal experience. Thank you. I will now move on to our next panelist, Mitavachan Hiremath. Mitavachan Hiremath is the co-founder and CEO of SusPoT, Center for Sustainability in Bengaluru. He has more than 12 years of professional experience in energy policy and climate mitigation domain. Mitavachan has a master's degree in renewable energy from University of Oldenburg, Germany, and completed his undergrad in mechanical engineering from National Institute of Technology, Jaipur, in India, MNIT. Some of the international organizations wherein he has worked over past years include German Aerospace Center, DLR, Wuppertal Institute for Climate, Environment and Energy, United Nations Climate Change Secretariat, UNFCCC, at Bonn in Germany, and the University of Oldenburg in Germany. He has also gained extensive research experience on climate change and mitigation issues during his early career work assignments at Divyansh Center for Climate Change at the Indian Institute of Science, Bangalore. Over the years, his work in the field of renewable energy and sustainability has been acknowledged by various national and international awards, including Mondia Logo Engineering Award from UNESCO and Daimler, Returning Expert Award from German Development Organization GIZ, Clean Energy Lab Fellowship from Shakti Sustainable Energy Foundation and Indian School of Business, ISB Hyderabad, and International Climate Prediction Fellowship for, International Climate Protection Fellowship for prospective leaders from Alexander von Humboldt Foundation, Germany, and German Federal Environment Ministry. In his research career so far, Mitavachan has authored and co-authored 15 publications in international and national journals, conferences, book chapters, and technical reports. I think Mitavachan has a unique portfolio in India. I think one of the few persons who really understands climate policy aspects. So very fortunate to have you. Over to you, Mitavachan.
Thank you, Vishal, and also Professor Subimal for giving me opportunity. And sorry, I did not really knew that you would be reading my profile, so I thought you would be doing selection. Sorry for a bit long intro. Yeah, so I'm very much happy to be part of this panel discussion. Basically, I'm a mechanical engineer turned into a policy researcher and sustainability entrepreneur. What we are really doing at SusPoT, Center for Sustainability, is we are trying to work with decision makers, entrepreneurs, and even general public, and in developing inclusive sustainability strategies and implementing action plans towards achieving climate neutral India by 2050. So my approach to career has always been need-based in the sense that how can I use my core competencies to address and contribute towards global and local issues, which we see in day-to-day life, and also which we are aware in general about what is happening in India and also at global level. So quite early in my career, when I was at Indian Institute of Science, I realized that climate change is one of the major threats to our and the upcoming generations. And to address these kind of time-constrained global challenges, be it climate change or resource depletion or even water crisis in Indian context, the policy design, especially, I mean, how you design policies and the implementation of policies play a major role. You can even see that, I mean, the countries that have good policy design and implementation and enforcement are at the forefront of be it climate mitigation efforts, or even as Vishal was telling earlier about COVID warrior, I mean, how they tackle the issues that are emerging. So that is the reason after my bachelor's, I wanted to have some kind of interdisciplinary exposure and go more into practical aspects. And I was just going through the course structure introduced by Professor Subimal, which I think I did not get this kind of a course in India at that time. So that is the reason I went to Germany to acquire further competence and expertise and spend good amount of time there. So over more than a decade now, my work and stint at various organizations, be it German Aerospace Center or United Nations or Wuppertal Institute, has been to develop required skill sets so that we can effectuate towards science-based policy making in Indian context, which I think very much is required. And also how to build network of teams, so that we as an organization or we as a team or group of organizations can contribute towards addressing sustainability challenges of our time. Because see, one thing I often would like to emphasize here is, I think this is the age of interdisciplinarity, multidisciplinarity, and cross collaboration. So, I mean, the people should learn how to collaborate. Often in the meet, we come across experts, but they are experts in their field, but they don't know the basics of collaboration and teamwork. But if you are really serious about addressing the global issues, be it climate change or any other global challenge, you don't have an option, you have to collaborate because the crisis and the situation is so much alarming and so much huge. We need teamwork. So I think through our work with startup and within India and even under Indo-German network, which we are trying to do, we are trying to develop our base and strengthen our activities in this direction. I think this will do for time being, and I'm very much looking forward for the discussion today. And thanks, Professor Vishal, for the invite. Over to you.
Thanks a lot. Yeah, thanks a lot, Mitavachan. You also highlighted this important point of collaboration, because interdisciplinary would happen if collaborations foster. I'm also hoping that in the discussion you will be able to tell us all and also the students more about policy, which is not much included in the curriculum. So with that, I will move on to our next panelist, Divyansh Chug. Divyansh is a PhD candidate at the Department of Atmospheric Sciences, University of Illinois, Urbana-Champaign, conducting research on land-atmosphere interactions over South America. He completed his bachelor's degree in civil engineering from our own IIT Bombay in 2016. He is former overall coordinator and an events manager of the entrepreneurship cell, E-Cell, at IIT Bombay. I think Divyansh would really kind of resonates very well with, I think, third year students, although he's now graduated and migrated continents and degrees. But I feel people would resonate a lot with you. Over to you, Divyansh.
Thank you, Vishal. I think time sort of stops when you're in your graduate school, so I still feel like an undergrad. And yeah, so all the students attending, I'm right there with you, learning from these panelists. I'm still a student. I started getting interested in this subject at the end of my second year. Like most of my friends, I had no idea what I'm doing. And so I attended these courses, fluid mechanics, hydraulic engineering, and there was something about these physical processes. There was a balance of physics and imagination that caught my attention. So I went to Professor Ghosh, and he handed me this problem, and he said, "See if you're interested in it." And I think that was the first hook. It was a simple problem at the time. I mean, now that I look back at it, but at the time, just reading that paper and working out through the concept and learning the technique, it took me a year, but it was challenging, but at the same time enjoyable. And so I guess what I'm trying to say here is that from all the other things that other panelists have said about sustainability, about the big picture stuff, just thinking about you as a student and your experience and your profile, working in climate studies will also teach you statistical and data analysis techniques. It will also teach you ways to answer questions that really need to be refined. You have to start with the big picture, see what kind of data or what kind of techniques are available to answer them, and then basically, come up with your own process to finally answer it as best as you can. So that's the kind of things that you can learn in a graduate program in climate studies. And then I continued working into my BTech project with Professor Ghosh and Professor Indu. And it was an interdisciplinary project because we combined meteorology over Northwest India with hydrology and geomorphology. So again, working in this area can give you experience in multiple fields, teach you a lot of things if that's something you're interested in. And finally, now I finished my master's from UIUC. I'm pursuing my PhD. Hopefully I'll finish in a few months. And it's focused on land atmosphere feedbacks, which teaches me that it's not just climate and atmosphere that we study. It's also anything that can affect climate and atmosphere, such as land, such as agriculture. We change our land cover, forests. We have completely changed 70% of the terrestrial cover over the terrestrial biosphere, and that has feedbacks into the atmosphere. It sets up chains of processes that can set up atmospheric events from small time scales to large time scales, and that's the kind of things that you can also explore. Similarly, there are feedbacks from aerosols, from all the other chemical processes going on land and in the atmosphere, and the list goes on. So there's just an endless list of topics that you can study in climate studies. And then finally, that brings me to my future interests, which is how future climate and how future projected changes affect agricultural yields, which is what I'm getting interested in lately. And basically, the idea here would be that right now we have a certain setup in this world, and we know how things work, and we know how much agricultural yield happens from which region of the world. But in a future climate, things will look completely different, and we need to be prepared for it. And so, since everyone's talking about climate mitigation, this is another avenue in which we need to be prepared for, is how do future climate changes affect human systems that we have already set up and we rely on so intricately and so deeply. So yeah, with that, I'll conclude my few minutes, and I hope you learned something from this session as I am learning, and thank you for having me here.
Thank you, Divyansh. Thank you for bringing up the tools aspect from the student's point of view, which is very important. And I hope we discuss that more later on and hear from all our distinguished panelists about the tools that we all use in climate sciences. Moving on to the next segment of our program. Now I will try to place myself in the shoes of the third year student and see as to if I were presented this opportunity, what sort of questions I would have had, and try to kind of ask you some questions from that point of view. So maybe I'll kind of start from Raghu, but please feel free to
Vishal,
chip in if you think.
Maybe you want to open it up for see if students have questions, because this is a one-way. Become one-way now. So see if there are any questions from students.
Sure. So what I could do is maybe I will, like Divyansh said, I'm still also, although I am a professor, but I think I'm still a fresh professor. So maybe I'll ask a couple of questions and then open it up. And if there are, as those are answered, maybe we'll chip in again if there is time. Maybe I'll start asking Professor Murtugudde as to you have seen this climate science field really grow for past few decades. So how do you think the field itself has changed? How climate studies programs have changed? And what do we need to do to really cater it or align it to climate solutions now?
I'm just going to answer it slightly differently, because considering this is aimed at students who are trying to consider dual degree, things since, let's say, I was student well before they were all born, was that the disciplinary boundaries were very strong. And so only after PhD level, I managed to shift directions. And that too, maybe it happened because I was in the US. In India, it's still kind of a bit harder, I think, because there are all kinds of restrictions on which department you can join and so on. So what has changed is, if you think about genetics, computer science, DNA, this, that, you can merge all kinds of backgrounds to go and work in different directions. IT students, no matter what degree they get, they can join IT, they can join finance, and they can go to PhD and so on. And we know that AI and so on are now part of everyday life. Your phone, everything you do, the search engine is collecting data. Every time you go buy something, they will innocently ask for your phone number and they send your data. So everything is part of life now. But what is different about climate is that it is affecting everything. So if you think about physics, chemistry, biology, and math of the climate, that is one thing about what you would learn. But it is affecting building codes, it's affecting infrastructure, the financial system, journalism, environmental science, medicine, and so on. So I think students need to get a view that whatever disciplinary background they get in terms of a BTech, having climate knowledge is going to make them kind of, I would say, doctors of the planet. They will have some sort of a background to look at planet and see if something is going wrong and whether they can solve the problem. So it doesn't have to be climate warrior. I would say be climate saviors, because warrior is kind of a strange word. What are we battling? Ourselves. We are the ones causing the problem. So be climate saviors. And there are solutions that are going to come from anywhere and everywhere, as you know by now. So cell phone is one platform, and Rajul talked about what she is doing, and AI and big data are there in finance. So greening the finance is one thing, greening the infrastructure, green technology. So India invested in IIT in the 1960s, and when in the 1980s the outsourcing boom hit, India was the only country which was in a position to exploit it. And now can India be in a position to exploit the green technology research and development in the coming decades? So you will be at the front line of it. So think about 10 years ahead, 20 years ahead, and where you will be. So think in that way, and having climate background at 1 year project and so on is going to put you in a very different level of understanding what we are facing as a climate change issue. But it is an enormous opportunity. So don't think of it as some end of the world thing, because I have done enough climate science. I can tell you world is not going anywhere. Biology is not going anywhere. We are already having problems. We will have some more problems. But the question is, are you up to the challenge? Are you able to innovate and use this challenge as an opportunity to deliver solutions? So all departments are trying to think in this way. That's the big change since I started climate science.
Yeah, thanks a lot for sharing the perspective. So I think the link question could probably be posed to Dr. Rajul, is how did she take her innovation from kind of lab to ultimately industry, and where there's a possibility of offering climate solutions that she sees in the way industry works right now in India.
So as I said that I wanted to build something which would have a social impact. As I told, was learning about this climate mitigation on the go, right? But one thing, it was very clear to me how much it was affecting climate change. I was not knowing those numbers, but definitely there were like problems like release of nitrous. Over fertilization will release nitrous oxide, which will add to greenhouse gas emissions. Now, how much that affects was not the numbers I had, but I know if I can reduce the fertilizer usage and if I can reduce the water, because I know that water usage in agriculture is very, very low, 30%. So, and 80% of the water is consumed in agriculture. So I know that if I can tackle these two problems, it will help agriculture. It will also help the climate change, right? It will mitigate. So these are the technologies. And as I said that 85% of farmers are marginal. Technology has to be built such a way that those farmers can use it. Until those farmers use the technology, we can't expect pollution, any changes happening, what we are expecting to happen, what we are expecting it to happen. So targeting technologies for those 85% of the farmers are the thing. I think I would say that Soilsens is helping in reducing the effect of all these negative effects on climate change by using these technologies.
Thank you.
I hope I answered that question.
Yes. I have a link question because climate kind of disclosing climate risk is becoming an essential part for that investors are asking for companies to do. So how do you think new kind of fresh graduates can contribute in this, in really kind of helping industries in kind of forming properly charted reports in disclosing climate risk?
Okay. So, I mean, I don't know, but let me just answer this question this way. The background of this thing today, I just changed it to tell you the effect of analytics, what can happen. This Nobel laureate getting the Nobel laureate on the analytics part, and this is the unseen potential of analytics, what you can see in the background. So industries are definitely looking at this kind of analytics, data collection, and working on that. And second, sorry, what was the question? Vishal, I'm sorry about that.
Yes, the second part was, as to how climate solutions kind of, how can kind of students know about industries and what sort of climate solutions that are required in the industry?
Yeah, so I said that analytics is one big everybody is talking about. Second is that solutions have to cater to the masses, right? That is what is required. And solutions have to be affordable if we are talking about India and bringing changes in India. The solutions have to be very much tailored to the Indian conditions, I would say.
Okay. Yeah, thanks. Mitavachan, do you think our understanding of climate solutions is aligned with climate policy? You have an expertise in energy policy. So can you tell us a bit more about where all there is a need for really bright minds to chip in and contribute?
Yeah, certainly. See, I mean, this whole, when we go to policies, I mean, see, this whole policies is kind of an intermediate field, you know. You can take it, it's a wash thing. So there are solutions, technology providers and academicians and science-based researchers on one end. And on the other end, there are politicians and decision makers. You know, there is a huge gap, especially in the countries like India. I mean, I would say the gap is pretty much pronounced compared to, for example, in Germany, where I have been a bit exposed in a better way. So, but see, the gap is huge. And in other words, there is a challenge, one, but there is a very good opportunity. Okay, and I can certainly tell based on our experience as a SusPoT. See, SusPoT is still a non-profit think and do tank, and we are youth funded and youth led. You know, I mean, still often, I mean, people question, see, you are still youth and young, how come you are into the policy space? Because the policy space and even the I mean, this whole space is dominated by the people who are, I mean, above, let's say, above certain age, okay, in Indian context. So, but the things are changing. We still exist in the market, and we are pretty much growing on yearly basis. So the things are changing even in Indian context. The policy makers are listening to the new technological developments, and there is bit alignment and refinement that is going on. But it is about how you bridge the gap, because we are kind of, I would say, policy researchers are kind of connectors, you know. And if anybody, I mean, any student, I would say, let us say student, fresh graduate, one is they need certain skill based training, okay, be it say using analytics as we were discussing, or even some advanced tools, or be it standard life cycle assessment based tools, or even some kind of interdisciplinary tools. That is one end. But at the same time, how do we use that tool to solve the issues that are existing, and these existing issues, and how do we communicate it to the decision makers the way they understand, you know? There might be certain problem and we are trying to address it, okay, but if you communicate in a scientific language or technical language, but the other person might not understand it, you know, although he might be trying to address the same thing in a different way. So it also the importance of education. I would say, I think not only education, the technical communication. Okay, it kind of plays a major role in the field. I would say that is something which I would say the students have to acquire. And I recently I did come across some of the universities, be it Imperial and some other universities, wherein they have this technical or climate communication wing, wherein they train people how to communicate these technicalities to the common man or the decision makers who don't understand the technical terminology. So these are some of the things I think which we need the young people to learn along the way. But in terms of potential and contribution, I would say even, I mean, within our own organization, wherein we basically are technocrats, kind of, we come up with technical skills and trying to address the policy issues. I'd say the things are changing in the domain, and there is a need for the problem solvers with technical and science background. There is no doubt in that, but it needs a bit more than just having technical skills, at least in Indian context, I would say.
Okay. Yeah. Thanks. Yeah. Talking about skills, I think Divyansh had mentioned about tools, and also I think Dr. Rajul mentioned about climate analytics part. So I would really like to ask Divyansh as to if there is a third year student who is right now in the audience and is thinking, okay, I'm going to subscribe to this course. How can he kind of utilize that extra year? So what tools would you kind of recommend him to equip himself with so that he can contribute in kind of either in academia or industry, depending upon if he has already made a choice for either of them? What are the most impact making tools that you would recommend and you have used?
From my own experience, 6 years ago, I remember that there are GIS courses offered in our department. There are data analysis courses offered in our department. And in my own journey, it started with time series analysis. And then there is this course in statistics that is also offered in our department. So basically, some sort of temporal, time series, and spatial analysis combined with statistics. That's really the core of it, right? So those are the 3 or 4 courses that I think would benefit the most before joining the program. And after joining the program, things that you can explore and you can learn are, for example, I have learned how to run and visualize weather forecasting models. I have learned how to model small scale processes like how a cloud forms. I have learned how to handle big data. So big data analysis using Python, machine learning, using all sorts of statistical techniques. And the best part is once you learn one of them or two of them, and once you get better at it, you realize that it goes on from there. You can actually learn anything because the basis of all these techniques is still your time series analysis, your spatial analysis, and your statistics. So I think there's a lot they can do within that 1 year of a dual degree as well.
Yeah, thanks. I hope we have touched upon some of the topics, but I think this is a nice time to open it up to UGs. So whoever is attending, if they have questions, they can raise hands and we will call out your name and please unmute and ask questions. So the floor is open to the attendees now to ask questions.
I see that in the chat they are asked to fill a form to ask questions, which probably, obviously, they decided this is not worth it.
Yes.
So,
no, they have been asking, I think, a few questions, but I think.
Well, why don't you read them?
Yes, but I thought
we should answer them.
Definitely, yes. I thought if somebody is present live and is really wants to ask, we could kind of offer them that choice. But I see no raised hands, so we could
also,
move
Vishal,
on to.
We can ask them to post it in the chart as well. In addition to filling it up, they can just post their question in the chat.
I've already asked them to post there.
Okay, fine.
Okay, so we have at least already gathered some questions. So I will request one of the TAs to unmute and ask questions on students' behalf from whatever they have from the list.
Yeah, hello. So this question is from Dr. DJ Rao, environmental researcher and consultant, and it's not addressed to any of the panelists in particular. They write that I'm currently studying the impact of the population explosion since 1950 on climate change. due to an enormous increase in agricultural production, increase in industrial production, ultimately huge increase in consumption. Can someone give perspective on this?
I can take it because I have written in Newsweek an article on population. Population gets thrown around a little bit around in climate issues. And if you remember, Europe and especially US was arguing that China and India have growing populations, so there is no point acting on climate. They will dominate anyways. But the problem is, if you look at per capita carbon footprint, it is 16 ton per person in the US, and China is now at about 7 or 8 ton per person per year. India is at 3 ton per person per year. And with education, women have fewer children, and they have fewer children so that they give more wealth to each child, which means the consumption level of each child is higher. So a woman with 4 children will have much lower carbon footprint than a woman with 2 children. So population is a very misleading item that is mentioned in the context of climate change. Climate change, I mean, population is important because it puts pressure on habitats, tiger conflicts, and over-exploitation of certain things. But under climate change, emissions, population is dropping. Fertility rates have dropped over the last 30 years. Many countries like Japan, Spain, Greece, Portugal, Germany are all below replacement rate. China has removed its one-child policy because their population is getting older. India is also now heading towards a lower population. So population is a problem that will solve itself. I don't think population is the problem. Overconsumption is the problem. 6% of the emissions come from food waste. Food is wasted. It is produced enormously and wasted. Grain production for feeding cattle is one of the biggest environmental damages that is done. So I would just be careful about blaming population for things under climate change umbrella.
Okay, thanks. Would any other panelists like to add on top of what Professor said?
Yeah, maybe I can add a couple of things, but I totally agree with what Professor Murtugudde was just trying to highlight. But in addition to that, I see the basic thing is about the resource consumption. I would say that is the major problem. I mean, the population as a whole might put pressure on certain things, but certain limited resources and natural boundaries. But see the whole thing, I mean, why the climate change happened in the first place. If you see, I mean, that happened when the population is not that much, I mean, over a period of 100 to 200 years, okay? And wherein the resource consumption and the emissions and the emission intensity, you know, of populated countries, although their population might be low, but their impact were high, you know. So it's about how many multiple factors of impacts you have. That's what determines, I would say, the problems like climate change or even other resource depletion thing, and also the lifestyle choices, you know. Say for example, I mean, the food is still a hot topic, but what kind of food you consume, you know. I mean, for example, in Germany, they're still trying heavily on technology front and all the other matters. But when it comes to food, they clearly acknowledge that that is a major contributor, but they cannot bring about the lifestyle changes, you know, because of various things. So, and also what kind of infrastructure you develop, you know, for the society or the kind of cities we develop, you know. We can have a pathways that are as simple as that will be helpful, or you can concretize everything, you know, like you see in some of the countries. So I would say the question is more on the multiplication factor of each populative, I mean, each person has, rather than the how many number of people living in a certain area or things like that. So I think that is a bit more significant.
So you're saying that the whole question should itself be looked at from different point of view, and we need kind of young people to take this up further. Yeah,
Yes,
thanks.
certainly. And also the lifestyle things, what kind of lifestyles we have, and I mean, avoiding extremities, you know, like ideals and extremities. I'll go to a common monks like kind of lifestyle, or other people having a lavish lifestyle. I mean, there are, of course, there are middle ways, and there are series of things in between. I think that is something which as a society and also as an individual, we should check on, okay, and wherein everybody can participate and contribute through. Yeah.
We got away a little bit from population there, but portfolio approach is one thing, because you can do calculations and show that a person who is driving an SUV and is a vegetarian has a smaller footprint than somebody who is riding a bicycle and is eating hamburgers every day. So you have to have a range of portfolio and track. You need a bigger philosophical approach. We always get into details. If you want to give everybody on the planet a 10-ton per person per year footprint, rich people have to come down, poor people can be allowed to go up. So infrastructure and other things have nothing to do with that. Population is going to drop, but consumption keeps going up, especially when women who are rich and educated and have fewer children, their consumption goes up disproportionately. So we need to focus on not population, but a portfolio of how we distribute our carbon footprint. So some kind of a equity justice is needed there as well.
Good point. I think there's one more question which is partially linked to this question. I would request TS to read that out as well. I think they've pasted it in chat already.
Yeah, so the question is from Hari Ramasubramanian. He asks, can the panelists explain when is per capita comparison appropriate and when is the total comparison appropriate in the context of climate change evaluation?
I can start. So per capita consumption is always important because that is what ultimately climate justice is going to be all about. Equity is going to be all about, because climate impacts are very disproportionately affecting women and children and poor countries and poor people. So rich countries have historically been responsible, but we have already gone past that argument, because in 1990 is when we became very aware of emissions and climate change. So the world has decided that we will do equal but distributed responsibilities, or whatever the word is, and each country will be responsible, but we will give concessions for countries who are behind in terms of green funding, technology transfer, and so on and so forth. There are global governance issues like total CO2. Net zero cannot be net zero has to be done at many levels to bring the global emissions to be flat. So CO2 is a very good global governance issue. Methane is much more non-uniform. N2O, which is mentioned several times. You have to be careful also mentioning different things in the same breath, because CO2 lasts for many centuries. It is in parts per million, whereas N2O is in parts per billion. Okay, so we have to look at concentration, life residence time, and global warming potential. So even though N2O is 300 times more powerful, it is 1,000 times smaller in concentration than CO2. So we have to be always careful about those kind of comparisons. So global governance issues of technology transfer, green funds, helping adaptation of poor countries, and monitoring CO2 and total equivalent greenhouse gases, because you have to convert N2O, methane, CFCs, HCFCs, etc., to CO2 level to understand total pathways. If you have a global warming target like 1.5 degrees by 2100 with 67% probability, or 2 degrees centigrade by 2100 with 67% probability, if you just focus on CO2, you will miss this by a lot. So you have to consider CO2 equivalent, which means all greenhouse gases. Okay, so that's where the global emissions matter, but per capita emissions are what are driving the global emission. So you have to carry both of them together. The best way to think about it is the energy intensity of all GDPs, carbon intensity of all energies. That's where all the crux of the matter comes down to.
Thanks, Professor Murtugudde. In some sense, are you also saying that there is a need for a collaborative effort where economists, climate science scientists, and management people sit together to define a new index so that they are comparable, they can be compared ultimately?
They are already there. There is the Gini index. There is, if you look on my YouTube channel, I've covered a lot of these topics. Paris Agreement already addresses many of these issues, and already banks are involved. There is impact investment. There is greening the finance system. So all these things are already happening. More rules are not needed. More indices are not needed. Just implementing what we have properly is needed. Because if you look at the Russian invasion of Ukraine, immediately the geopolitical perturbations and Pandemic, for example, affected climate action greatly, right? A lot of economies suffered after the pandemic, and a lot of funds were allotted to revive economies. Those funds were indiscriminately allotted to things that are not good for climate. So as soon as there is a problem, we forget about climate. Russian invasion of Ukraine happens, US says we'll supply more gas to Europe to protect it, but this will create more emissions than getting it from Russia. So climate action will always be on the back burner when there are perturbations. So it's not about making new indices, it's about sustaining climate action no matter what happens.
Okay, yeah, thank you. Yeah, can we do, does anybody want to add on top of that? Or we could move on to the next question.
Just a thought maybe. One, I totally agree in the having the indices and I mean implementing it, that is very much needed. But one thing I would like to add, basically with my association with some of the German movements and, for example, degrowth movement that is happening in across Germany and other sustainability movements that's happening in India as well. You see, I mean, at the same time, we need, I would say, some kind of change in basic models. I mean, how the economy works, you know. Say, for example, still the majority, we consider GDP as a growth factor. These are kind of blind indices, you know, that we want to grow always. See, in a finite or limited world, I mean, we having an indices that always goes on growing, and that even the mindset. I mean, we need the models that change this mindset, not support it, you know. Say, for example, if you look at the recent economic the changes that are coming, for example, ecological economics, or even the steady state economics. For example, the steady state economics try to develop the model when the things are steady state, you know. Otherwise, our economy is always like ever growing. I mean, even they want all the curves to always go high. I mean, these kind of things we think we need to address and change that mindset, and also we have to bring these into the models that the govern the society. Say, for example, be it our GDP indices and some other indices. I think wherein I would suggest we need a bit of implementation and innovation in changing the models, you know, how we make decisions, because otherwise we'll be still stuck up with the same trend, and we go on and like I mean, like it goes on exponentially. We'll have, I mean, we can, for example, we can try to address the climate issue, but something else will pop up, you know, unless you maintain the steady state lifestyle or the balances. Okay. So,
but that is the point I was trying to make. Herman Daly wrote since the 1970s about how sustainable economy should work. And there is now the donut economy and circular economy. There are many models. Issue is not more models. Issue is that the Victor Lebo in the 1950s was the first one to say, nobody knows who he is. He's a retail salesperson who said, only way to grow economies is to build things that don't last long. And of course, this model was used. So it's not, models exist and they have been proposed. GDP, there was gross national happiness defined as well along the way. So changing GDP will not change the model. It is still coming back to energy intensity of GDP, carbon intensity of energy. So you can keep GDP, right? All life forms use energy and pollute. We are just very good at it. So it is not that we will change our lifestyle dramatically. It's just that our energy has to be non-polluting. And India and China have both flattened their energy intensity of GDP already. And they are kind of saturating their carbon intensity of GDP as well. So I'm not sure necessarily more models are needed. It's just that we are still missing on the energy intensity and carbon intensity. Anyway, I think students are getting lost, so let's ask the students. Yeah.
I think Divyansh had something to add on top.
Right. Thank you for that discussion. I just wanted to steer it into the direction of how students can utilize everything that we just heard. Both Professor Murtugudde and Mitavachan, they both touched upon multiple topics in which students can play a role or start to study things such as monitoring of CO2 and NO2 levels, be it satellite-based, be it ground-based technologies, working towards sustainable solutions such as soil monitoring, soil health, water quality, how, as Dr. Rajul also mentioned, how excess fertilizer can degrade soil quality, how it can degrade water quality. You can study census data, utilities, electricity consumption, get into that sort of thing and see how the behavior is changing in terms of consumption, or how we can steer it towards more sustainable consumption. So all of these things you can start doing as a student through this dual degree. But these things have long lasting impacts, and you can actually build your whole career in it. You can really contribute to society in it. Again, that's the kind of stage where I'm at, where I'm thinking what to do in future. So yeah, that discussion was really helpful, and these are the takeaways that students should be thinking, I think, at this stage.
Yeah, thanks a lot for putting the whole thing in perspective from students' point of view, which was essential, I felt. Thanks a lot for that. Okay, let's move on to the next question.
The next question was asked by Arush Kaur, who's a first-year student at IIT Bombay. How can a background in BTech chemical engineering help in the dual degree project?
I think Subimal can answer that.
Thanks, but any of the panelists want to answer? Raghu, if you want, that's fine.
Well, if you, sorry, I'm talking too much, so you can ask. Okay, so Divyansh, you want to say?
No, please go ahead. I'm still articulating my thoughts because I know somebody from chemical engineering who works in this space. I'm trying to think exactly what they do to just provide an example. But please go ahead.
So one of the greatest thing you can do is right now for a country like India where climate change is already here, we don't need projections for 2100. They are useless. They are uncertain. Nobody uses them. We need things for next year, for 2030. So what do we do for next season? Monsoon is coming up. So you need early warning systems. India has spent more than almost 900 crores to develop good models, and forecasts have improved from 1 to 3 days, 3 to 10 days, weeks 2 to 4, and seasons. These can be converted into what are called early warning systems. Subimal is doing some of this work where you develop early warning systems for food agriculture, so irrigation advisories, crop selections, and so on, and for health. So that's where chemical engineering comes in. Air quality, water quality. India is leading in diarrheal diseases in the world. We are worse than Nepal, Bangladesh, and Pakistan. Okay, so the quickest impact you can make as a chemical engineer is to work on water quality. Let's say you find a way to crowdsource water samples across India and just measure E. coli and map E. coli. How much E. coli are you consuming? E. coli doesn't make you sick, but total coliform is a good indicator of other pathogens. Air quality, there is Chandra Venkatraman who is doing aerosol work. Fuleria is doing air quality work, and he's also, I think, doing some health work. There is the Digital Health Center at IIT now, the Kota, I think it's called Kota Digital Health Center. So chemical engineers have the best seat in the house in terms of building early warning systems for health. Okay, so go for it.
Raghu, are you saying that in some sense? Sorry, Subimal. So for the first year student to really write to one of the professors and start from there and get to know about what all expertise IDP climate studies already has to know more about the problem. Sorry, Professor Subimal, please.
I think
I'm on
must
campus. Just come and talk to me. I'll buy you coffee and explain to you what is happening. Okay. Go ahead, Subimal. Sorry.
Yeah, so just to add that our
I just want to add here
32 faculty members.
I think there is probably a bit of overlap. Dr. Rajul, if you want to proceed, and then maybe Professor Subimal.
I just wanted to tell him that we also, whatever the soil health sensors we are developing, I mean the soil related sensors, one product what we have developed is a glucometer for soil, which is based on electrochemical sensors. So there is a lot of chemistry involved and chemical engineering involved in those kind of systems what we are developing.
So just I wanted to add that if we consider our faculty strength, out of 32 faculty member, I think more than 7 are from chemical engineering or chemistry. So you can understand that there are a lot of chemistry and chemical engineering components, starting with atmospheric chemistry, starting with carbon sequestration technology development, starting with climate and health, air quality, water quality. So chemical engineering is a major component of climate. So as Raghu has said, just wanted to tell that a good proportion of faculty members are also from chemical engineering and chemistry.
Thanks, Professor Ghosh. Arush, I think
to
what
add,
I would. Yeah, please, Divyansh, please go ahead.
No, I'd just like to add a quick point. Like it would be fantastic to start right from your first year. Although I'm sure they would have their own course load, to get used to and do their first and second years properly. But specifically for chemical engineering, I know a lot of people here are involved in studying and improving industrial engineering techniques. They study how production happens in industries, and then they try to either improve it so as to create less waste and less emissions, or analyze what kind of emissions it is creating and what can be salvaged from those emissions, such as to create products from that waste that instead of just discarding, they can actually be utilized. So there's a lot of things that you can do as long as you keep in mind that this is the direction you want to go in, and just do your courses over the next 2 years. By your third year, you will figure out how you can get into this space through chemical engineering.
Yeah. Thanks, Divyansh, again for translating that to the from a student's point of view.
दिखा दीजिए तो शायद मेरी बात का यकीन न माने आपकी बात पे यकीन मान जाए। मैं इन्हीं शब्दों के साथ मुझे खुशी है बात की एक बहुत
I think there's somebody speaking. Okay, thanks, Ahmed. Yeah, I think for Arush, I guess the take home is probably that if you are inclined more towards industry, please get in touch with Dr. Rajul. She will tell you more about the sensors she is developing, or he has already developed. More academic and want to get kind of explore more, take Professor Murtugudde's offer and have a coffee with him, or get in touch with Professor Subimal, who will introduce you to the whole set of faculties. Please feel free to drop an email. Yeah, so shall we move on to the next question then?
Yeah, this is the last question we have on our list, and it's been asked by Govind, who's a first year MSc PhD Energy Science student at IIT Bombay. And his question is, can a first year master's student take part in the interdisciplinary program?
Professor Ghosh, will you like to?
Yeah. Yes, thanks for your question. So this is essentially designed for the undergrads who are in third year. So from third year, they can switch. But let's say if you are a master's program in energy science, and if you want to do a, let's say, if you want to do a master's project in the specific area, so there are a few faculty members from energy science. You can visit our IDP Climate Studies website and find there are a few faculty members from energy science who are actually working, who are also associated with climate studies. You can actually have your master's project with them, probably co-supervised by another faculty member from climate studies, so that you can have an interdisciplinary master's project in climate studies. You have the freedom of taking electives. You can pick up some of the electives from climate studies. So this will help, and in the future, if you think or you're thinking of a PhD, you can actually do a PhD in IDP climate studies, extending your master's problem, or outside, if you want to do any other institutions, you can do a PhD in climate, or if you want to join a company or open a new startup, anything you can do. So this program is not for undergrads, but you can definitely do a project in climate studies, because there are quite a number of faculty from energy science who are associated with climate studies.
Thanks, Professor Ghosh. We could move on to the next question.
Sir, this was the last question on our list.
Okay, so in case somebody has a question, want to raise hand and ask, please raise your hands and we will let you kind of unmute yourself. Then we'll call out your name. So in the meantime, maybe I'll kind of try to ask question which is a bit less, I think, explored. I feel that US and United States is there's a big boom of climate analytics. Some of the companies have also put in their private satellites, have got funding for that. There's a huge potential for using AI, ML, Internet of Things, and such technology in providing climate solutions. So in some sense, I wanted to ask all four of you, all of them, or rather all of you, as to how well are we prepared? What are India's strengths or IIT graduate strengths in addressing this? Where are we in some sense? Maybe Dr. Rajul, can you kind of express your thoughts on
India
this?
is well prepared. Yeah, India is, if you have seen the name company, there's one of our IITB Monash student has joined that company called Pixel. I think it is called PIXEL. So that's a company which has got a 25 million USD funding recently and is putting satellites for climate studies. So that is one of the examples I can say for the thing you mentioned. So India, and there are companies like, there are also doing international meeting. That is the very recent example I can tell you, which is putting satellites in the space and got really good funding.
Yeah, thanks. Anybody else?
There is Skymet, which has already put up its own network of observations, which presumably it uses to downscale to the private company. Plus, I think Subimal can say more, but monsoon mission funding from Ministry of Earth Science is going to ask for public-private partnerships, if I'm not mistaken. Subimal, you want to add?
Correct. Yes. No, nothing to add, but you are correct that monsoon mission is now they will promote the new startups and they are going for more collaboration between new startups, newer companies, and with the researcher and academicians. So they will be promoting and for towards making better climate services and solutions. That's the objective.
Plus, I can tell you from personal experience that Plaksha University is offering 3 times the IIT salary to recruit people in climate, and Geo University is offering US salaries to recruit people in energy and climate. These private universities are aiming for Ivy League kind of model. So don't be surprised if in a few years they are building partnerships with ISRO and international agencies to go in the direction of more drones and satellites, small satellites and other platforms to generate their own data as well.
Raghu, can you please translate this for how bachelor students should hear it, where he can chip in?
If you are getting a dual degree here and Geo University is going to start soon, then you can go join Geo University for PhD, or you can join Plaksha University, which is in Mohali, which has already raised $100 million of private capital. It is started by the same people who started Ashoka University. All of them are IITians. They made a lot of money and they have taken the model that private education in India is going to be big, and the government obviously supports it because Geo was selected as one of the institutes of eminence. So it will be a shame if in 100 years, in even 20 years, there are not Ivy League type institutes in India, and IITs should get them run for their money, because right now they are getting a lot of funding from the government, but they are not totally in tune with many things. So if private universities begin to raise a lot of research funds and start doing research and elevate the whole thing. See, in the US, it works very well, right? There are state universities, there are private universities. There is always a case to be made for state universities because you want education to be affordable and accessible. So India will continue this model and should continue this model, but India needs very good private universities, research universities, which are coming up.
Thanks. I think Dr. Rajul has a question, probably an independent one or maybe a follow. Please. Dr. Rajul, over to you.
Yeah. See, I have one question here. We are actually discussing about IIT and their third-year students, but just out of my own curiosity, if there are students from a different college and a private college, because Professor Raghu just spoke about private colleges, like undergraduate from either electrical or computers, and if he or she is interested in climate studies and want to pursue this maybe in Germany, because here or maybe in Germany or Europe, what is the best possible way for, is it possible for an electrical engineering student to go for MS and maybe
maybe
Mitavachan can that.
Yeah, so essentially, I'll tell you at this moment, IITB Climate Studies has a PhD program. We have not yet started master's program. We are starting with the IITB program, and soon we'll start the master's program. That's the idea. Now, for a PhD program, even if it is open to all the disciplines, so we are not really restricting any of the discipline. The idea here is that the ideas should be fresh and interdisciplinary. That's the idea, and because of which we are not really restricting any discipline. There are students from electrical engineering, electronics engineering. There are students from computer science. There are students from civil. There are students from mechanical. There are students from chemical. There are students from humanities and social sciences. So we have all sorts of students who are actually doing PhD in climate studies. So let's say if you're opening the master's program also, of course we'll open it to any discipline. But of course we'll have something like there should be some qualifying gate, like something related to environment, or maybe they are qualifying some qualifying gate score would be required as per the Ministry of Education rule. Otherwise, we are kind of open. So IITB Climate Studies, the main idea here is that let us make it open to all the disciplines and bring climate component into all the disciplines so that we can come up with a better climate services and solutions. That's the idea. That's the objective of our IITB Climate Studies. And I think they already, IISc has a Center for Atmospheric and Oceanic Sciences where they take master's students from all the disciplines. So that's the way it works. So climate is kind of in an area where students from any discipline can join. But there is only COS, one department which is there in IISc, but that is only focusing on core atmosphere and ocean. But now here it is open, like we have climate science, climate adaptation, mitigation, policy, everything, and we are open to all sorts of people, all sorts of students, young students. So this is the way it will work. So I think there are a lot of opportunities.
Thanks, Professor Ghosh. I think I see Mitavachan has a question and raised hand. Please, Mitavachan.
It's actually, I wanted to add a couple of things to your previous question, Vishal, rather than this thing. So I would like to also to add, see, there is good amount of traction in startup space as well in the recent years in the domains of AI, artificial intelligence, data analytics, even climate risk management and related consultancies for, companies or across the thing. Okay, even drone based data collection and all, even in to certain extent in think tank space also, and they offer very lucrative salaries. If people say some students who might be interested in coming back and working, okay, after their masters or even bachelors in this space, I would say they can also target the upcoming startups. They offer very competitive salaries, okay, in terms of if that is their criteria. But there is good amount of traction when it comes to data modeling and kind of field-based data collection, be it agro-based, using drones to get the agro data, things like that. So this is something, but we need to see, how much would be sustaining, because Indian startup space is a bit different than, for example, be it US or Germany, for example. But it's just I thought of adding this.
So a related question in some sense to all panelists is that, is it because kind of students are not aware of enough aware about the climate change, or probably they don't have this masters in climate study which kind of equips them with the tools to ultimately form startups? What are your reflections on that?
I think you have to remember what Steve Jobs said. People don't know what they want. You have to show them. So climate change is happening. It is affecting everybody. They don't know that climate change is happening and affecting them. So you have to create services. When Rajul mentioned climate services, that space is where you can basically come up with ideas. For example, there are more cell phones in India than toilets, as they always say. If you can use that platform to build instruments, embed on them, sensors that are for virus, bacteria, just as an extreme case. But temperature and humidity are easy enough. Nitya Ramanathan of Nextleaf in LA is developed cell phone-based indoor air quality monitors, and she is funded by the World Bank and so on to look at impacts on women's health and so on. So there is infinite opportunity, but you have to find a space. Not everybody is going to be an entrepreneur, right? Not everybody. Some people are going to get climate MTech and maybe go to PhD. Some people are going to move into Swiss rehires, Munich rehires. So there is climate jobs coming up, but you have to be aware that climate PhDs the employment rate is very low. Even though it seems like every institute is hiring climate scientists, it's a cloning business. So you get a PhD, you become a faculty, you produce more PhDs. This is not a sustainable model in the long run, unless there is something useful to be done beyond just producing PhDs, right? So students have to educate themselves, and having a MTech obviously gives you a very good sense of the policy space that Mitavachan is talking about, or the other observational platforms that he mentioned, and what Divyansh is mentioning in terms of how they can build tools or use tools, and what Rajul is mentioning in terms of instruments and so on. So I think the one-year project that they do has to be used as a way to explore that space. Where do they want to go with that? So one-year project is an excellent idea instead of sitting at courses or in long discussions like this, which are great, but actually in the end, they are not that useful, right? So projects, on the other hand, are very useful to actually do something.
Thanks, Raghu. In fact, in adding to that, that's the idea we have used. So in IITB, the committee thought of making it more project specific. So maximum credit has been given to the projects. So it's a 1 year. Last year there is absolutely zero coursework. It's entirely project work. For other IITB programs, what I have understood from different departments, there are coursework. But here in IITB climate studies, it is just made very much project heavy. So there is a project for 1 year. There are only very few courses which are basic minimum which are needed. But we want the students to really learn from working on a specific project related to climate services and solutions. Thanks.
I think this also resonates with, I think what Mitavachan said, I think think and do tank. It's not just think tank, it's think and do. I think that's what probably you both want to highlight. I think this guy, I think Professor Murtugudde. Yeah, please go ahead, Dr. Rajul.
Yeah, I want to add here that, okay, all we develop technologies, models, AI, sensors, drones, everything. What is required is that policy reforms, everything is fine, but what is required, how do we change the mindset of the people, right? Until those people change and use. So that is also one of the most important things that students should be taught to, like, go and talk to these people and understand and how you create awareness. I think that is one more important thing one needs to look at.
Thank you.
Yeah, I would like to add the same lines. I think because see this, I mean, which you also asked, Vishal, I think. See, I mean, this whole sensitization and bit creating awareness about what is happening to the students, early on. I somehow feel that is bit we are lagging in that, be it the climate change, even about some of the other issues. Because I have seen some of the election propaganda in Germany, wherein Green Party, they use climate science and related facts to sensitize common people. Okay. I mean, but here when I see, forget about the common people, even the students who are, technically advanced, their masters or PhD, they know what they're doing, but they are not sensitized about the external world, affairs, be it the critical issues but climate change and others, many others, they are not sensitized. So if they are not sensitized and aware about these, how do they think, to solve that? Because first we have to introduce them to these things, right? If even not possible through formal education, through some other education platforms, because this is what we are thinking as our SusPoT Center for Sustainability as well. How can we, in the coming months and years, develop this kind of mass level awareness and sensitization events so that we can at least give some push here and there to the younger generation on thinking about, addressing or at least contributing to these kind of affairs, Otherwise, they are already given training and everything. They come directly to the field after their master's or PhD. Then they start thinking, but they cannot alter back their professional, their career development, right? These kind of things. So,
yeah. Thanks,
I'm
Mitavachan.
very skeptical about this behavioral change aspect. A lot of studies have been done. Very simply, as they say, kids do as the parents do, not as they say. So 99.99% of the climate scientists who talk about end of the world are living a perfectly normal life, worrying about their next car, their next house, their savings, and so on. So I think unless climate community actually lives as an example, expecting people to change their ways is kind of, we shouldn't even bother with that. Just produce solutions. People buy things and they cannot track carbon footprint. So if the system is something called carbon trap and carbon fractal. Everything we do, everything we eat, go to work, how we go to work, how far we travel, everything has a carbon footprint. So the system has to change. So we can, obviously sensitivity is very high now because the Fridays for the Future is a big movement and awareness is very high. Any media in any language anywhere on the planet has a climate story every day. If this doesn't sensitize us, nothing will. So those who are sensitizable are sensitized. Those who don't care ever. So I think we have to just focus on solutions.
I think that is a great kind of point, I think, to ponder about, and also I think do ultimately action both on the IIT side to train good masters level students who will understand the problem earlier on and then can provide solution. I think probably I would like to thank all the panelists for this thought-provoking discussion, and sorry for kind of overshooting a bit in terms of time. I hope you all don't mind, and also apologies to the attendees because this has gone a few minutes beyond calculations. Before you all leave, we would like to kind of record your feedbacks. One of the TAs has shared the feedback form in the chat. Please take kind of couple of minutes to fill it in. But I would like to thank all the panelists again to kind of, they took their time out and to discuss this important issue and brought in their individual expertise to this discussion, which made it, I think, not monotonic, but from all different perspectives. I'm hoping that students will be inspired from this, which was the main motivation. I
Thanks,
think with
Vishal.
that, yeah, I would like to kind of conclude and thank you all.
Yeah, on behalf of
thanks,
Climate
Vishal.
Studies, I thank all the panelists for joining, all the attendees for joining in the late evening, and thanks Vishal for conducting it. Thank you very much, everyone.
It was my pleasure.
Yeah,
Yeah, thank you.
and all the best
Please
for
fill
the
in the
program.
feedbacks. Please
Nice
give
meeting
us feedback.
you, Mitavachan. Nice meeting you. Rajul, I think we met before, but yeah.
Yeah, nice
So,
meeting
Yeah, I
you.
think the
Looking forward
students
to
will
catch
take
up sometime.
probably a group photo or something.
Divyansh also I met before.
Right?
Okay.
We ran into each other during the summer.
Yes. Okay.
Vishal, I think the students will take a group photo or something. So Krutika or someone will take, right?
Yes, sir. I'll take a
Yeah,
screenshot.
all of us will just switch on our video so that.
Just smile and
Yeah.
say boo.